tell you out of bacteria. tmRNA, it's always on the exam, so is the next one. So, again, we're going back to this big picture. There's always quality control to make sure the RNA gets out there. And one of the things that we talked about, and just one of the things that we talked about, is that the RNA is circularized. The RNA is circularized because there's a cap. In fact, it can bind to the cap both in the nucleus and in the cytoplasm. Once in the cytoplasm, the factors that bind the cap, initiation factors 4G and 4E, also bind the poly-A binding protein to quasi-circularize the RNA. We also know that if splicing happened properly, that every single splicing junction should have an exon junction complex on it, these little red guys. If things happened normally and we took the introns out, then each and every intron should be gone, the two exons should be spliced together, and an exon junction complex should be on every single one. Remember that I said a lot of things are decorating the RNA when it's inside the nucleus. Some of those decorations are left inside the nucleus and don't exit the nuclear pore. Others do exit the nuclear pore. Exon junction complexes are one such thing that does exit with the RNA. So when we're looking at RNAs like this, once ribosomes have gone all around them, as they're translated, the ribosomes physically sort of just knock the exon junction complexes out of the way. By knocking the exon junction complexes out of the way, they're actually increasing the half-life of the RNA and allowing it to be translated for a long period of time. But let's imagine that splicing didn't go so great. If splicing didn't go so great, we might leave an intron in this. In this case, we've left the first intron in this. And such that this RNA that it was exported actually has an in-frame nonsense codon in it. If that's the case, the ribosomes will terminate at that in-frame spot, as they should, through normal mechanisms, and the rest of the RNA will never be translated. If the rest of the RNA is never translated, then this exon junction complex is never removed from the RNA. Now, exon junction complexes are sort of like magnetic bombs. If an exon junction complex comes out with your RNA, it's an immediate sort of target for proteins that you guys need to know as UPF proteins, these little green monsters on there. There's a whole variety of green monsters. So every exon junction complex is an immediate, favorable target of the UPF proteins. As the RNA emerges into the cytoplasm, UPF proteins start binding onto it. And they sort of start forming one of those dog piles that kids do on the playground, right? Like one kid goes down, another kid jumps on top, and they try to like squish the kid on the bottom. It's the same sort of thing that's happening. You need to reach a critical mass of interactions with UPF proteins. Once that happens, the RNA is degraded. So you have a balance in the cell. If translation starts right away, it's going to knock the exon junction complexes off. Because there's no way for these UPF proteins to dogpile on top and get rid of the RNA. But if you screw up splicing and you block translation by a nonsense codon, you can get nonsense-mediated RNA decay. Katie O'Donnell's ticket to a professorship. So in nonsense-mediated decay, if a nonsense codon is present in a transcript, either in an intron or artificially introduced, the half-life of that RNA will go dramatically down. And it was a hard puzzle to figure out. How does the cell know? Like, it made it to a stop codon, it's fine. How does it know that the rest of it should have been produced? And it knows it should have been produced because there were remaining exon junction complexes here. Those remaining exon junction complexes end up being the landing pad for UPF proteins, and as more and more UPF proteins get there, degradatory mechanisms are put into place to get rid of the RNA in its entirety. Once it gets rid of the RNA in its entirety, it's basically thrown out the garbage and waits for a new RNA to come out. So every single RNA that comes out of the nucleus that is spliced and is bound by exon junction complexes